Well, hello internets and my 24th subscriber now. Yeah, last time I said that this antenna coupler is actually looking peachy, but it's not. At a closer look, we have this little resistor here, which has developed some sort of yeah. As you can see, it has some black marks on the right pin, and it even has a, what do I use to point, like here it has a crack on it, right? So well, not everything is peachy after all, right? mm, Now let's try and have a look under the thermal camera. You can ignore basically everything that it's now in the picture because those are just reflections. Let's try and power it on. Okay, and this when on, it draws about 600 milliamps, and well, some things are getting hotter than the other, and specifically our resistor here, come on, resistor here is getting warmer. It's 40 degrees, 45 something, and this IC over here, it's also getting hot, but I mean, it's hot but not in, I would think it's a problem hot, because this IC actually has to turn on 5 relays, these guys over here, and these are turned on, and so at about 600 milliamps, that's about normal. So I don't know what's up with that. This is the power draw. So yeah, when you plug this in, you get power through the resistor. That IC goes boom, and this relays, like 6 relays or 7, I don't know how many of them, turn on. So that IC is working. It is getting warm, not hot. So basically working as intended. I don't know what should I do with this. I mean, I'm gonna clean it a bit with IPA. But if you have any other bright ideas, yes, I'm open for for comments and whatnot. So again, with the thermal camera, we have like 5 relays here, 6 actually, and 4 more here, so 10 relays, 12. I think that's it. Yeah, 12 relays. I'm gonna have to see where those relays are commanded by what I see, because I know for sure that relays from 110 to 115, I think this one and this one and something about here are commanded by this hot IC. This is now standing at, if I can get my finger off, at 40 degrees, and I figure the other ICs should be like, hot as well, but this is like hotter. I really don't know what to say, and I can't think for, I don't know, a situation when this resistor will get blown up. I mean, except if you put there like more than 14 volts, but then again, all the relays are clicking. Yeah. Let's have a look at the schematic. I had to download Firefox browser because in Firefox you can draw over things. So we have relays. Where is it? K101 and IC6. Then we have relays from 8 to 15. So 8, 9, and I'm gonna do this because these are all on the same IC basically. So IC number 8 does a really hard job. It's turning on like 7 relays, and so it sits at about 40 degrees. The others ICs turn on the difference, which would be like 5 relays, 2 of which on IC6 and 3 on IC7. So I don't know what to say, man. At the current draw of 5-ish, 600-ish milliamps, this is about right. No overcurrent, no nothing drawn, no, I don't know what's going on. The short, it's actually right here. I don't know how this got shorted, I have no idea, and the rest of 12 volts goes to relays like this. So yeah, how can this point specifically be shorted? How can this resistor and why? I don't know what to do with this. The resistor now drops about 0.9 volts, and so the current draw on that resistor is about 100 milliamps. I don't know if that is a lot for the 5-volt logic on this board, but I guess until I don't put a load on it and we get into the situation where this will actually draw more current, I can't actually do anything with this. So I will have to put a load here, not today, of course, and maybe not in the near future, and get this capture in a situation where actually that resistor wants to get even hotter than 40 degrees Celsius as it does now. So for me, I would say that's like 7 relays by this IC getting like 40 degrees is okay. I would pass that as acceptable. I don't know the current drawn through that IC, but we can have a quick mass. Yeah, wait a second. So we got the data sheet here, and something else bothers me. Like this IC is 6284 AP, and it's actually a 6 to 15 volts PMOS CMOS compatible, right? So how is this running of 5-volt logic? As you can see, this is the table with recommended operation conditions, and here in a minimal, where is it? Input voltage, right? For this specific IC, it's 8 volts. How is this running off of 5 volts? I have no idea, but they all are running off of 5 volts, so yeah, I don't know about that. Okay, so we have like 600 milliamps, right? Divided by 12 relays. So each relay draws about 50 milliamps, and this one device, I said it's powering up 7, and so it's drawing 350 milliamps, right? Is this okay? I have literally no idea. It does like 50 milliamps per channel, but this power dissipation, if we go 0.45, and what is the current drop? I think it's 0.7 volts. Let's do 0.9. So yeah, we are okay, I think. I have literally no idea. Yeah. So that being said, I'm going to back this, and I don't know, make space, make way for new projects. I have to get this sorted out, and this space, and that space, and that space. Next, we will try to adapt the microphone to the radio. Next week, I hope. Bye.